Welcome to this video. Today we'll talk about partial fraction decomposition, and integration by partial fraction decomposition. It's not too bad, it just has a really fancy name and kind of a long process to work with. Let's go ahead and jump in an example and get started here. I have the integral of 2x plus 3 divided by x squared minus 9. Well, that can be a bit of a difficult problem to get into. U sub might work, might not. Well, the best thing to do is partial fractions on a problem like this where you have a fraction that doesn't give you too many other choices. And to do that, the first step is to factor the denominator. So 2x plus 3, and then this will factor out to x plus 3 and x minus 3. And then I should add my differential on the end. Now, what do I do here? My next step is to kind of make a generic statement about this. And what I want to do is say x plus 3, x minus 3. Is I kind of want to say, well, this sort of equals, I'm going to separate my denominator factors, and I'm going to say some number divided by x plus 3 added to some other number divided by x minus 3. All I did was I split my factors and I put a generic number in the numerator of each one. Now I can begin partial fraction decomposition. And I'm just going to make a separate space up here. I'm going to say forget this problem, for just a second. And I'm going to say a divided by x plus 3 plus b divided by x minus 3. Well, that's going to equal our original thing, which is 2x plus 3 divided by x plus 3 times x minus 3. And what I want to do now is multiply by this denominator, both sides, to get rid of these silly fractions. So when I multiply everything by x plus 3, x minus 3, I will come up here. This whole thing cancels out because it's being multiplied, so 2x plus 3 equals, and then this x minus 3 is going to cancel out the x minus 3 under b, so it's going to be x plus 3 times b plus, and then we've got an x plus 3 in the denominator here, x plus 3 in the numerator here, so it's going to be x minus 3a, because that's the one that doesn't cancel out. Oh, there we go. Fantastic. Well, now we want to solve for a and b, and we absolutely can make a system of equations, but I'd like to tell you about an easier way to do that. If I look at this and I can say, well, if x is 3, then 3 minus 3 is going to be 0, and 0 times a, that gets rid of a, and I can solve for b. So I'm going to do that. I'm going to just compute this whole thing with x equal to 3 to intentionally get rid of my a, and that will solve for my b. So 2 times 3 plus 3 equals 3 plus 3 times b plus 3 minus 3 times a. A cancels out to 0. Simplifying this, 2 times 3 is 6 plus 3 is 9 equals 6b. That means dividing by 6, 9, 6 equals b, which reduces to 3 halves. And we have that value for b. Why don't we go ahead and do that for a as well? So I look here and I say, well, x plus 3, what value would make that equal to 0? Negative 3 plus 3 times b cancels b out. So I'm going to go ahead and do that. I'm going to say 2 times negative 3 plus 3 equals negative 3 plus 3 times b plus negative 3 minus 3 times a. What does that simplify to? Negative 6 plus 3 is 3 equals 0b minus 6a, and that's going to be 3 over negative 6 equals a, which equals negative 1/2 for a. And we have just done a partial fraction decomposition. So now that we have our values for a and b, we refer back here and we say, well, my original integral we know equals these values, And now I know what my A is, and now I know what my B is. So I'm going to go ahead and plug that in, and I'm going to make some more room for myself up here. So A is negative 1 half over x plus 3 plus B. Oh, I'm sorry, B's value is 3 halves. That's going to be 3 halves over x minus 3 dx integral. So how do we integrate this? We can look at a few different ways. Ultimately, we're going to end up with natural logs. So I'm going to say negative 1 half times 1 over x plus 3 plus 3 halves times 1 over x minus 3 dx. And now I can really easily do my natural log integrals, which is going to turn out to be negative 1 half times, and then the derivative of x minus 3 is just 1, so it's the natural log of x plus 3 plus 3 halves natural log, and the same thing, derivative of x minus 3 is going to be 1, so natural log of x minus 3 plus c. And that is integration by partial fraction decomposition. That's a pretty good example, but some of these problems may have more than one term, and it might get a little bit confusing trying to cancel things out. So I'll do another example with 3 terms, and you can find that problem here. Please subscribe if this was of any help, because that is the best way to help me too, and I will see you next time.